Hello guys, so my name is Amit. Today we will talk about hashing. Okay, so in the previous lecture we have seen IP hashing, consistent hashing, so many things, right? And we had one word in common, that is hashing. So before we deep dive into consistent hashing, I thought to give a small overview about what exactly the hashing is all about, right? So what is hashing? So hashing is like a machine. Okay, hashing is like a machine that takes any input you give, okay, and it converts to a unique looking number. Okay, it converts to a unique looking number. So what that means, suppose you give any input, these are hash functions, okay, and you give any input here, okay, it can be a string, a number, object, anything, right? It will generate a unique number for it. Okay, same if you put any other users, I'm considering the object as a user, right? Suppose you have given user 1 here, it generates a number 3984752, and you give another user here, it generates a different number. Okay, so what exactly hashing is? So that means you provide any number or any object or anything, right? You provide anything, right? It can be number, a string, object, anything. What it will do, if you hash it, it will generate a unique number. It will generate a unique number. That is the hashing is all about. Okay, that is the hashing is all about. So the whole idea is it will generate a unique number, right? So suppose you got two objects, one is user 1, another is user 2, right? So on a fundamental, what we know that if you hash this user 1, it will generate a different number, it will hash the user 2, it will generate a different number, right? But if the user 1 and user 2 is same, right, then the hash should be same. Based on our definition, the hash should be same. Suppose you want to compare whether this user 1 is same with user 2 or not. So there is one possibility also you can do, right? You can hash both user 1 and user 2, right? So what it will do? What we said, that it will generate a number, right? So it will generate a number. I am considering number 1 and it is generating another number 2. Then we can check, right? If number 1 equals to number 2, then user 1 equals to user 2. Can we say that? You got this point? So hashing is what? You can hash any particular object and this hash will generate a unique number. So if this unique number is same, that means this user can be same, right? This user can be same, right? Because as you said, the unique number, but it is not guaranteed, but most likely the user and user 2 will be same. Why it is not guaranteed? Then what has actually promised to us, right? What has actually promised to us? Because just now I told it will generate a unique looking number. Now I am telling it is not guaranteed that number 1 and number 2, even though those two will be same, the user 1 and user 2 may not be same, right? So then does not has promises to generate the unique number? Yes, 99.99% the hash will always generate a unique number, okay, for a unique object. You got my point? But hash collisions is possible. So what hash collisions means? Means for different object also hash can generate same number. That called hash collisions. Okay, it is mathematically possible, but it is very rare, very rare. I mean, that will not happen. 99.99% these hash collisions never occurs. Okay, but still there is a chance mathematically the hash functions will not give you 100% surety of generating a unique number. Okay, there is a slight chance of 0.1% that it may generate same number for two different users. Then what are the promise that hash do? So the promises of hash is doing is same input. If you has the same input, always it will generate the same output. Okay. So what that means? if the user 1, the hash output is 984752, that means tomorrow or after a year or after 100 year also, if you hash the user using the same hashing algorithm, it will generate the same number. This is what the hashing promises. Okay, this is the first one, same input, same output. Okay, then what is the promise? Any small changes in the user, any small changes in the input, right? If in this input you just did a small changes, right, the output will be completely different, completely different. So what hashing means? What hashing is telling? Hashing is telling, if you provide me same input, always I will provide the same output, but if you do any small change in your input, I will provide a completely different output. Okay, so this is what hashing guarantee. Okay, this is the hashing promises. Okay, next is the distributions should be even, right? What that means, right? Any hashing algorithm, suppose I am talking MD5, right? MD5 is a hashing algorithm, right? And it works with 1 to 8 bit, right? So it works with 1 to 8 bit. That means the number it will generate, this hashing algorithm will generate from 0 to 2 to the power 1 to 8. Okay, so in this range, the unique number will generate if you use MD5 algorithm. If you use CR16 algorithm, it works with only 16 bit. It works with only 16 bit. That means this particular algorithm will generate a number from 0 to 2 to the power 16. Got it? And this SHA-1, this is a very strong algorithm. SHA-1, the range of output is, right, it is using 160 bit. Assume what is the number? Range 0 to 2 to the power 160. So the range of MD5 is very high compared to CR16. CR16 only works with 16 bit and SHA-1 works with 160 bit, that means 0 to 2 to the power 160. So distribution should be even. What that actually means? That means the number, the unique number that this hash function will generate will always be distributed evenly across this range. Okay, so it will not always from 0 to 500, right? Never. It will be across this range, you know, evenly distributed. I mean, if one number is 1, another number may be 10 lakhs, another number may be 3 crore, like that. So that means it will not be very close to any particular area. It will be, you know, evenly distributed. So if you can see this in a graphical format, that means, so suppose I am taking a, you know, range, right? Suppose this is 0 to 2 to the power 16 and this is CR16 algorithm that we are using. Okay, so the number this hash function will generate will be distributed evenly. That means it will be in a range of all this area. Okay, not any close to any particular area. No, it will be evenly distributed for all the range, right? This is also hashing guarantee. Okay, this is also hashing guarantee. I hope you got it. What is the hash promises? Same input, always provide same output. Any small changes in the input, it will provide completely different output, and the hash numbers will be evenly distributed. So that means what I told, from 0 to 2 to the power 16, this is the range for CR16 algorithm, and the value of these hash functions will be evenly distributed in this particular range. Okay, it will not be enclosed any particular area, it will be evenly distributed in this range. Okay, so this is the hash promises. So another thing is, okay, what we talked about earlier, right? Hash collisions, right? Hash collisions. So what is hash collisions? Right now we will discuss. So what is the output range? Output range is 0 to 2 to the power 16, right? For CRC algorithm, or CRC16 algorithm. But when you talk about this is the output, right? This is the output. But when you talk about the input, right? Input is, there is no range, right? Input is infinite. Input is infinite. So when the input is infinite and output in a range, so that means any two input can be mathematically can be possible to give the same hash number, because output is limited, input is infinite, okay, output is limited, input is infinite, right? So what that means, suppose input is nothing in infinite and output is limited 0 to 2 to the power 16, right? So now each input you are doing hash, right? So now the hash is giving the hash number, right? But then mathematically it is not possible to provide unique number always, right? Because the input is limited, output is limited, input is infinite, right? So suppose if you are generating hash, if you are generating hash for maybe 2 to the power 1 lakh input at once, so it will generate output in 2 to the power 16, right? Now you don't have one-to-one mapping on any number of input to output, right? Because the number which you are using, the number you are using in the input is much bigger than the output, then definitely there will be hash collisions. That means one hash number may be generated for two different input, but this is just a theory. In practical it is very rarely happened, and the chances of getting the hash collisions is very less, right? That's why a good hashing algorithm makes that extremely unlikely, okay? If you use a good hashing algorithm like this MD5, CR16, SHA-1, so this makes it is very unlikely, okay? In Redis, CR16 it is they are using, there might be happening because range of CR16 is smaller, right? But if you use SHA-1, the range is very high, right? So you may not get the hashing collisions, it will be very extremely rare. So you don't worry about hashing collisions, hash collisions for now. Just I wanted to understand, okay, what is the term of hash collisions is, okay? I hope you got it till now, right? So now you saw there are three types of, there are many hashing algorithms. These are the famous hashing algorithms. One is MD5, CR16, SHA-1. Okay, this CR16 is very famous because Redis cluster, right? I will talk about later, right? What is Redis? Redis cluster exactly using CR16 algorithm. Okay, to exactly what happens in Redis, right? They have multiple nodes. They have multiple nodes. Okay, in the where they are actually storing the cache. Okay, and they use CR16 algorithm to find the nodes, okay, and distribute it, distribute the load evenly between all the nodes in Redis cluster. Okay, so same way load balancer also use one hashing algorithm, that is SHA-1 also load balancer use. Peer-to-peer network connections, right? When you use peer-to-peer network connections, they also use SHA-1, and CDN, right? You use CDN consistent hashing, they use MD5. So there are, like, you may get, like, if you do a Google, you will get like all the hashing algorithms and where exactly we are using these hashing algorithms. But I want you to understand the whole idea of hashing, what exactly hashing is, right? So just wanted to give an example now, right? Suppose this is a load balancer. Now this is a load balancer, right? And this load balancer using IP hashing, right? So that means when the user request coming, right? So what it is doing? It is hashing the user request, right? And based on these hash functions, it is deciding which server it will send the load, right? S1, S2, S3, S4, right? So now the user request, suppose the hashing key, it is checking the user ID. So based on user ID, it is sending the hash. So what hash promises? Same input, same output. So if the user ID will always be same, the hash will always be same, and based on hash, if it is deciding a server, then the server will always be same. You got my point, right? This is called the IP hashing. So IP hashing is the load balancer algorithm. So which exactly getting used, in the sticky session, right? For sticky sessions, where we have studied all these things in the previous lecture also, in the sticky session, right? Where we need to send one user request to one particular server. Okay, so this is IP hashing. In the next lecture, we will study all these things in detail. IP hashing in consistent hashing. So just now I thought of giving a high level overview of what exactly hashing is and what is the hash promises, and how you think about hashing. Okay, in your previous next lecture, when you study consistent hashing, IP hashing in detail, then you will be able to relate properly what exactly hashing is. Okay, thank you so much. This is for today.